Practice, stop, drop, and roll.
Our things every year, and taking a whole class out, we go out to the soccer field, and we'd have to, they had the field, we had to practice stopping, dropping, and rolling down the hill, go back. Fire safety.
There's nothing to hide under this. You're under it. Yeah, let's do more. Yeah.
I think I was third or fourth grade.
Never had that. Something like sirens go off in Cedar Park, but never.
In the East Texas country, not young, there was one, we had to huddle. There's actually one day comes occasion, former mother remarried, we all huddled in the closet, her room, put a mattress against the closet door. And that was our little cubby hole. The second one was a year or two after she was married, we all went to the bathroom. In the bathroom. Well, yeah, we didn't have hurricane problem. We had tornado.
All right. I guess we'll keep it kind of simple. I'm not going to talk about anything code related because I just don't offer legal advice. But it varies so much, man. Like, general rule of thumb is if it's a big piece of equipment, the fire alarm should be shut off. If it's a rooftop or a large package unit or air handler, it's probably going to have some kind of fire shutdown. A lot of fan power boxes, I think the rule in Austin is like 2,000 feet per minute or something like per second, whatever. No, it's per minute, right? Yeah. 2,000 feet per second. That would be it's big. It's like that's moving. No, so for 2,000 CFM, I think it's the cutoff in Austin. Look, there's Kurt. Yeah, anything 2,000 or above is typically what we find them on. But yeah, I mean, that still varies. A lot of times you can have smaller ones that have it, so we'll put them on there because we have to. So like if the fan can do 2,000 CFM, then it's supposed to be shut down in Austin. So other places that and even in Austin, that still varies because like if it's an old unit, we don't touch it. Some jobs make us put fire shutdown, some jobs don't. It just depends. Typically speaking, though, at least as far as we're concerned, we just go off whatever they tell us needs to be shut down. We don't make any decisions or choices. You're solely functioning on what an engineer specified needs to be shut down. So they'll tell us, hey, this fan power box, this fan power box. Usually, if they're doing any of them, they do all. So, as far as like air handlers and stuff go, it was just a lot of that stuff is already done, and we're just rewiring it or changing it up. But new install stuff, a lot of units come with them pre-installed, and then they just add a shutdown. And that's simple to wire it in across a set of contacts. There's a couple different ways fire systems function as far as shutdowns. They have what they call supervised and unsupervised setups or systems or contacts, whatever you want to call it. Like take an AON, for example, will come with a built-in smoke detector in the return or supply. and it will shut itself down when those trip. Those are not tied into the fire alarm anywhere. They're just local to that unit. And then what you'll get is the fire alarm guys will run, they call them like MR101s or BS101s, just a couple different names for it. It's just a dry contact. They have voltage going to it or no voltage on it, depends on how the system's wired. You wire it up with a normally closed contact across the emergency shutdown to the AON. When that trips, shuts the unit down. So they can shut down when somebody does a pull station or they get a general alarm somewhere in the building. That'll shut the unit down, even though it doesn't have smoke physically in the unit. Most equipment will have, I don't know how the rule works on smoke detectors versus shutdowns, but like package units, big equipment usually will have some kind of smoke detector, either supply or return. Smaller equipment generally will have just a relay that the system is telling you to turn off. I know 9 times out of 10 for us, manpower box wise, there's no smoke detector. We do have buildings that do have smoke detectors, but a lot of them are just relays. And then a VAV box has nothing because it's fed through. So you shut the air handler down, it kills the box. Fan power boxes, because they have their own source of airflow from the fan, you have to shut them down separately. The big thing about the supervised stuff is if you come across a relay that's supervised, and if you kill power to it, it can trip the fire alarm system. So us, in general, don't touch the relays or the annunciator or whatever's there. We focus solely on the equipment side of this aspect. So like when we go do a retrofit or a build out, we supply a whip and we'll go and run it over to that relay and the fire alarm guys wire that up. If we can get them to do it, we try not to ever do it. We exclude it in all of our stuff. It's a liability we don't want. If we wire it up wrong and it doesn't work, they complain about us, say we did something wrong, and it's just a fiasco. So typically speaking, we'll run a whip to them and let them wire it, but a lot of times they wire it wrong. So, most times you're going to have your system wired up normally closed, where basically you can wire it on our wire, our system will run. As soon as they break it apart, it'll shut everything down. The issue we run into is some fire alarm systems are hot, like so they have power going to them, and then when they have an alarm, they lose power. So those you would wire up normally closed or normally open because it's hot, get power sent to it. When it loses power, it opens up, fails up. The other ones are the opposite. They don't have power going to them. When they have a fire, they send power to them. So those you have to wire them up the opposite way. And it just kind of can be, you got to talk to the fire alarm guys, find out how they have those relays set up. Smoke detectors, the beauty of a smoke detector is, it is what it is. It doesn't matter how their system's set up. You just pick a normally open or normally closed contact depending on how your equipment is wired up. So most of the time when the smoke detector senses smoke, it'll open the set of contacts or close the set of contacts depending on which way you have it wired up, and it shuts your equipment down. So some smoke detectors are addressed and supervised, some are not. Like I said, like the AONs, they have the built-ins that aren't supervised. Some of them. That's 5 points. I just looked over and see this bright blue hat. Okay. Like, he's usually way dirtier. Huh? That you usually dirty? That's how he hides the fact that he doesn't work. He just gets, he makes it look like he did a lot of stuff. So yeah, if somebody ever says it's a supervised, contact, that means that it's actually addressed. And like you can go to the fire panel and see like node 26, and they can apply node 26 to a specific piece of equipment. That's really helpful if we're getting like alarms through the fire system and they're blaming it on us or something. And it's like, hey, go check this unit. Other times you can't do that because they're not supervised, and it's just smoke detector trips, and you've got a unit off. So, I don't know. When y'all don't really do installs, huh? Holden, how do the guys, we do like equipment change out stuff. Are we responsible for that, or do we hire people out for that kind of stuff? Do we
Most of the time, we almost all of them we do ourselves.
Okay.
It's pretty rare that we sub them out. Current.
Yeah. But on like putting in a new smoke detector and everything, even if it's a supervised smoke detector?
What will happen is if we have if we do have one we need to replace and it requires any kind of programming, we'll go do the work,
Yeah.
put it in, and then tell the customer, all right, call your fire company.
Just trying to figure out how y'all were dealing with the addressing side of things.
We'll work on the component. That's
Right.
part.
Yeah. That's something we try to stay away from as much as possible because it's life safety. We don't have a life safety license. So technically speaking, if we do it, it should be recertified by a life safety. So it's just why, like I said, we try not to mess with them as much as possible when it comes to firearms. We'll do it, but a lot of times we end up having to wire them up on the TIs and stuff like that, just because if they've already come through and mounted those relays, they don't want it back. They're like, no, we mounted our relays, just wired up. Oh yeah, yeah. Yep. Yeah. And a lot of equipment has unsupervised stuff, so it's not a problem. If you have an unsupervised smoke detector, you send it 24 volts and you wire in a set of contacts. It's done. There's nothing else to it. They're super simple. So it's just the supervised ones where they have like the daisy chain red wire coming in that you have to worry about. Yeah. Yep. Yep. Exactly. Yep. Yep. Yeah. So anytime you see a system that has like an in and an out for wire, that's typically going to be supervised. So that means it's hooked into a system, it's addressed, it's had to have been set up and commissioned inside the system, and you unwire it. I can't say anything. But actually, you bring up a good point. So if you ever go to a unit, you see like a red box, like 4 inches by 2 inches or something like that. That's more than likely a fire shutdown. They also come in like these little white 4 square with a little blinky red light on them too. Same deal, just a different kind of relay. A lot of times, the white ones with the flashing red light are supervised. The red ones are just dumb relays. They're just got voltage going to them, and they just open and close a set of contacts. They're not actually monitored by the system. But the ones in the like a 4 square junction box with a little red light that flashes, those are usually addressed. So if you undo one, they go off. So, but the little simple red boxes with the 2 wires coming in and out of them, we just run a set of wires to bring 24 volts, shut your equipment down. Pretty simple. I'm done. Yeah. 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 That's just a standard duct detector. Some of them are addressed, some are not. Like I said, it just depends on the model. So a lot of lot of times they're just dumb, just dry contacts. You send them 24 volts from your unit, power them up. Yeah. Contacts to kill your fan, or if you have like a safety input on a board. Yeah, the magnet's tested. So all the magnet does is open up that set of contacts. Yeah, it's just an override. Some of them you can push and hold a button to test them. Some of them have magnets. Just depends. They're pretty simple. Power on and put them close to set of contacts when that little sensor in there sees.
Oh, okay.
They, typically, no. When you do that, it will set off the fire. Some do. Yeah, like I said, so that's the difference in supervised versus unsupervised, right? So like if it has COM bus going to it, what's like 2 red jacketed wires or white jacketed wires or yellow or black, it depends on what company's running it. They're addressed and they can set off the system if you test it. That is a good point, actually, I'll make. Anytime you're working on a fire alarm, think you're going to touch it, whatever, get with the building engineer, tell them to put the system in test. It will save you so much headache because you don't want to pay to have AFD come out. They don't have to, trust me. It's actually not that much. I think it's like $150. Right. It's more of a, they get pissed off at you and look down on you and, you know, yeah, this guy made us put our clothes on and get out of bed playing video games, you know. But I mean, they have a valid point though. If you make them leave for a nuisance call, they may be missing a real call. You know, you're pulling a resource. So it.
I haven't seen anybody fire department call them yet, but I'm sure it happens.
Yeah, we've participated in a couple. So, but yeah, if you, another thing just to add in, so with asking a building engineer to put stuff in test is like, say you do PMs, you only test the heaters. Anytime you light a torch, anything. If, dude, honestly, kicking dust up in a electrical, in a mechanical room, like sweeping up after yourself, can set them off. I've done that. I've been on a job site and I've been sweeping a floor, cleaning up, and set off a fire. So I know I said I'm going to talk about code, but I think part of the new code is they actually have to put a smoke detector on the ceiling of certain mechanical rooms as well now. And I set one of those off in a building one time, sweeping. Yeah. Yep. Because it's all it is. It's you know, like the spy movies where they got to weave through the lasers. That's what it is inside that little thing. It's a little. It's like an optical eye, and if particles cross that, enough particles, it trips. So think of it like tripping a laser or like the little beam for your garage door. Like that's what it is. Anytime you break that is what sets it off. So dust can do it, smoke, refrigerant, like anything that can break that beam can set that. Yeah. Even condensation, anything. All kinds of stuff. Set off. The laser grids. Oh yeah, they're still there. The ones up top? Oh yeah. I'll set them off too. So we have a building that has legit, it is like a laser system up in a real high ceiling. And it's kind of like a motion detector, like we sit up in the corner of a room, but it throws this little thing out. I don't know, and if it breaks, it freaking goes off. Yeah, not at all. What? No, it's out your arm. Yeah. Like in what was that? That No, not Mission Impossible. It's one of the Umbrella movies or whatever. They go down that hallway and the little grid like cubes the guy. Yeah, Resident Evil. That's it. Yeah, Umbrella cool. I couldn't think of it. Yeah, cubes you right there. Yeah, I guess it's like that. Throw your hat up and just check. But yeah, man, a 5-second phone call with a building engineer to say, hey, put your system in test, give me 2 hours, whatever. We'll save a dial out. So, like a lot of times when we're wiring systems up on buildings, we'll request that they shut it down the whole day. Like, hey, just kill the system. We're gonna be wiring up 20 fan power boxes today. We don't want to risk tripping something. And only if there's a fire somewhere that you don't know. Right. So the system still trips. It'll still set the alarm off. It just doesn't dial out. And then they have to pick up the phone and dial out. That's all it is. The system still works.
Hey, I'm here.
Just depends on what we're doing. Yeah. So sometimes, like I was saying, you're taking 24 volts from your unit, you're powering up that smoke detector. If you turn that unit off, it starts sending a trouble code to that fan. Yep.
People downstairs.
Yep. Same thing. Yep. For us, it's like, so we're messing with all kinds of units, turning stuff on and off. We get like an automation PM in the building, we're firing all the heats in the fan power boxes. Sometimes if they've sat all year, those fans don't have filters on them. It's blowing all kinds of dust on the heat coils. As soon as you light one off, it throws smoke. We did one in a building downtown, flooded a lobby with smoke after a TI. It was pretty bad. And then the funny thing was the next day, it happened while we weren't there. The fire alarm actually went off and the fire trucks came and we were sitting at lunch going, is that us? But it actually wasn't us, something called. So that was
Thank God.
the lobby out. It hadn't been on test. That was a serious problem. So, did they still show up that day anyway? Did somebody call them? Like, I don't remember. It's been years, but I don't know.
Fluctuating a little bit. That's okay.
Question. Say, that would screw me up. Yeah. Oh, that's right. We got Curtis, but he goes by Curtis. Call me Bud. All right. Well, I guess we can go into like how to wire them up. Okay. So I know this is a contentious subject between some of us. So there's a couple different ways you can shut stuff down. Obviously, you can kill power to it, right? You take the same 24 volts that powers up your circuitry, run it through the safety, and you shut the whole thing down. One way to do it. You know, it can be problematic for us because if you do that, you shut the entire piece of equipment down on a building automation system, we now see that unit is offline, right? It doesn't show it as operational, it doesn't show it as off due to a fire alarm, it just goes off. Well, then somebody may not ever go look at it. They may just be, oh, I just lost communication, may not think anything of it. Well, if you leave it running, leave the equipment on, and you just kill the fan, then you're like, all right, well, why is the fan on? And then you may go look at it because you know it's still operational, it's just not functioning properly. So if you kill the fan, that gives someone a reason to know, well, my fan's not working anymore. I have an issue with the unit. I go look at it, find out what's wrong with it. You see, oh, it's a smoke detector strip or something. If it's a non-supervised, don't get a fire alarm panel alert, then you have to go look at it to find out why it's off. Not every building engineer will go look at a unit just because it drops offline for a day. They just don't, hey, it dropped offline. Stuff does that. The other way is you can kill just your fan command. We run into problems with that sometimes where you kill a fan command and the compressor will continue to run because it has no fan status interlock or anything like that. Then you can trip out on high head. And if you have a manual reset safety, then you got to go reset a manual safety somewhere. It just adds in another thing you got to do. My preferred way is to kill everything besides your main board. So if you've got like a relay bank or whatever it may be, you kill power to that entire bank of equipment. So like the way we wire stuff up is we'll have our box, got bank relay, big transformer, power comes in, number through. That way, fire relay bank. None of these can come on. It'll kill everything. Cooling or heating, whatever it may be, it's the fan, it drops it all out. Some systems, we don't do it on ours because they're not UL rated for life safety, but like Johnson Controls can do it depending on how it's set up. I know like ALC can do it. There's a couple other brands that will actually monitor a fire contact on the equipment and shut it down through the controller. So your fire contact may just come in to an input on the control board. They monitor that input, they kill their outputs are coming out of the controller through logic. Ours can't do that because they're freely programmable. So like I just get a blank sheet and I can write all the program I want. You would have to get each iteration of a program tested and verified through the UL laboratory in order to get it ready for life safety. Do that. So our equipment is not UL rated for life safety. If it's like application specific and you just pick how stuff functions, those can be rated. But most of the time, a building automation system is not going to be rated for life safety, except for a couple of oddballs. Johnson Controls, because they have fire panel stuff, they have something. Same thing with ALC. I think Siemens may have something or but then you're relying on the function of that controller to shut everything down. Whereas like this, it's simple relay logic. You're putting a set of contacts, that's the power, that's all those off, everything shuts down. No ifs, no ands, no buts. It works every single time. That's the relay. That's another story. Right, so yeah, so this would be a normally closed contact right there on the fire alarm that's always sending voltage over this relay bank. When that contact opens up, it breaks the voltage, no longer have voltage going to that relay. Even though the controller is calling for this relay to be closed, you no longer have voltage going through it, so we can't do anything. And the reason I like to do it this way versus say taking the controller and taking the output out of the controller, it goes to the relay and breaking that. A lot of relays can be manually overridden. They'll have like an override switch on them. If somebody overrides that relay, well, that contact is closed. It'll still send voltage. But if you kill this, it doesn't matter if this is closed or not. It has nothing to send. So therefore, it can't do it. Something we just came across on a job is why I recommend doing this setup is we had a unit, like let's just say this is our fan. If I call for fan and I killed this here, it would shut down. But if I was calling for cooling and the fan, whenever you call for cooling, internal in the unit also called for fan. So you can literally fire just Y1 and it would bring on cooling and the fan internally on the board. So we were killing just the control wire to fan. And because it was calling for cooling, it wasn't shutting the unit off. The fan continued to run. So we wired it up how we thought it would work, and it worked fine when we just ran the fan. But when we ran heat, cooling in the fan at the same time, even though this relay fell out, Y1 was internally calling for fan and cooling. So it was just a little, had to test it and figure that out. And we were like, all right, well, let's just move to this function. That way we don't have to worry about killing everything. We're not doing the full 2 hours. It's holding in, but reducing our time. Oh. I guess the main thing to always think about is just if you wire up a fire alarm, test it. It's the simplest thing I can tell you. Because like us, when we had that issue with the fan and the cooling, we didn't know because we tested just the fan. It worked when we tested it, but then when you call for cooling, it didn't work. Simple, just test will fix that problem. Tested it, but we didn't fully test it. So the definitely want to reiterate the putting things in test when you do anything on fire alarm. Even if it's changing out a dumb smoke detector that's not hooked to anything, you may find out it is hooked to something. It may be tied in with another safety. It could be that that smoke detector may not be part of a daisy chain and it may not be supervised, but there may be a wire on that fire smoke detector that goes to a supervised input that you don't know about. You take that smoke detector off, you open that contact up, it sends a signal, strips the whole building, puts a smoke fire alarm, sends people out to the street, they get rained on, it just makes for happy. So, yeah, actually, I've sent the whole building out into a parking lot that got rained on. Luckily, it's a small building. People don't like it. It's nice when it's a nice sunny, cool day and you get to step away from your desk for a few minutes. But if it's raining, it's bad. That was a long time ago. I made that mistake like 6 months. A couple years. But yeah, if you can get the system put in test, it's always a good thing. Then once you do wire it back up, just check it for function. Because like I said, some systems need to be wired up when we open, some need to be wired up when we closed. Depends on how that fire alarm system is set up. It's one of the things that's always kind of thrown me for a loop is some systems will be set power normally, and some will not be sent power normally. I don't understand the ones that are not sent power normally. If you're going to send it power in a fire alarm, that just doesn't make sense. Like, what happens if the system fails because of the fire, and then now it's trying to bring equipment back on? It just doesn't make sense. But fire alarm guy, so we'll come across some where they're powered when they're in the alarm. Don't get it. Happens. Yeah, they can try to come up with more material that we can talk about on the fly. Smell smoke. For a second. So that's something that I can't speak to. Don't know. But from personal experience, I have seen it both ways. I have seen where specific equipment is shut down based on, I guess it would kind of play into how big your building is, right? If you know you've got firewalls and stuff, you can shut some equipment down, leave some running. Some systems have smoke evac that will actually purge your building. Some of them shut everything down. Some of them pressurized stairwells, depending on how tall the building is. I think it's 6 stories. Anything over 6, you have to have stairwell pressurization, which basically flushes your stairwells. But it can't be overly pressurized because then you can't open doors. So.
Setting that all off, or you have to have several.
That's programmed, right? So that's something that we don't mess with. And typically on those though, anytime there's a fire alarm, that stairwell pressurization kicks in. It can be one alarm anywhere, it kicks in, because if they're clearing a building, they have to do that. So most, I think the code is that a door into a stairwell has to open in, you can't open out. Because if people are rushing a door, you can push them up against the door and then nobody gets out, right? So it has to open into the stairwell. Well, the problem with that is once you pressurize that stairwell, you now have to push against that pressure. So stairwell pressurization systems have to monitor pressure across those doors. And they can only have like 0.005 feet of water column against that door. So it has to take just a small amount of pressure to open that door. It's like what we did building the other day was we wired up some VFDs for stairwell pressurization. All I went out there after you, they were all shut.
Yeah.
Well, I had to get it off, because the lady on that floor, like, she ran around. I was like, okay, good. I think
Over pressure. It's just, and it, they didn't want to
I
run.
was on somebody. Yeah, we were trying to figure out what box was something here. You were telling me it was 3 door closers all on one floor on the same side of the building.
We had to-
Yeah, we had to prove that it wasn't us in order for them to look at the door closers. Because they were,
I was out there. So,
engineers convinced, the door guy came out and said it's not the closers. He said it's not the closers are fine. But like literally he went out there and then I came out the next day. I did the same thing. I shut the unit off. I shut the outside air off. I shut the ERB off and I shut the air handler off. I had no air movement on that building and it still would not close. That's what I had to do.
no, I turned the unit on, and the doors closed. I turned the unit on, and it ramps up really slow. About the first minute or two, the unit was running, the door was shut fine. You know what? 5 minutes later, I walk outside all.
So there is a pressure difference across those doors, right? There, I mean, because you're drawing air. There's those grills up top, and air's going to take the path of least resistance. So you open up an 8-foot door, air's coming out of an 8-foot door instead of a 4x4 square, right? It's physics. So, but they would not overcome that little bit of pressure. No, it was not us. Yep. Yeah, everything was working. I turned everything off in the building, and they still would hang open just a little.
See, when I turned it off, they could shut fine, but that lady said that she could turn up how fast the door should. I got them adjusted all the way up.
They're all the way up. They should be slamming shit. They won't. So, but no, that was not us. They put new door closers in. And see, the thing is, the main reason I thought it wasn't us was because the other floors are all set up the exact same way, and it's a single unit that does all the exhaust and supply out of that floor. All the other floors work fine.
So they had one exhaust.
Yeah,
And then on one side of the building,
and the other side.
and I was like, wait a minute, what's this? There's everything.
There's only that one. There's the one for the bathroom on the one side, and then there's one right there by the same one that ducted all the way to the other side of that bathroom. But they're just toilet exhaust. They're not building exhaust. So the building is balanced pressure-wise across the building, but it's a whole other subject. But yeah, on the stairwell pressurization stuff, they have to maintain a certain amount of pressure. That way those doors can be pushed open by elderly people and handicapped people and stuff like that. Can't take the stairs in your wheelchair. But yeah, so we actually have a test coming up. So yeah, we have to do some. I've mounted the panel and ran some poly and stuff for it today. We have to test it all. We're waiting on the breakers to come in, so that's going to be a whole commissioning. And fire marshal's going to come out and test those doors. It has to be certified. Like it's a whole thing. But when we wire those up, how we'll say like our stuff can't do life safety. The VFD can do life safety. That VFD has an internal program where there's a fire contact. And when that contact is tripped, that VFD ramps up and does a certain thing. So, and then it'll take an input and ramp itself up and down to maintain that pressure. Set the parameters, but the program is there, right? It's adjustable, but the program is there. There's a fireman's contact on that VFD, forget which terminals it is, and there's a program you can select. And when that contact closes or opens, however you set it up, it does, right? Doesn't matter if you've got it hand, auto, off, it'll do its thing. Overrides everything. The only way you can stop it is to kill power.
We lose some of the contacts. Not going to,
Yeah.
because they come pre-programmed, but you cannot turn it off.
You can. You just got to go in pretty deep.
So we jump it down.
Yeah.
And it'll tell you the schematic, jump it.
Yeah. You can turn it on, but you have to go pretty far in the program to turn it on. But it is doable. But yeah, so the way I'll wire it up is we'll have a 0 to 10 input coming in from a static pressure sensor. It has hard poly going down to the floor and monitoring pressure across those doors. We have to do an average. It's 9 stories, so we're doing 3 different floors, like 2, 6, and 8 or something like that. And then we're doing 2 floors. 2 floors, okay. Yeah, so 3 and 6. Okay. There's a certain number depending on how many floors we have to do. And then we monitor pressure across those. That sensor sends a voltage signal to the VFD. I set the parameters of that sensor in the VFD, and then I give it a set point. Once that contact trips, it does its own shit. You can't stop it if you wanted to, unless you turn power on. Pretty cool. One of those things where we're not allowed to do it with our controllers, so we have to physically wire everything up to that VFD. And we're supposed to use a UL rated pressure sensor and all kinds of stuff, which we do. So, which most of those pressure sensors are.